All right, some of you have been asking about these two questions, or I guess the series of questions 2.6, questions 10, 11, and then I think 17 and 18. I'll do a couple of these, give you an idea of what you're supposed to do. They're just asking for X and Y in these problems. So the first thing you gotta do is just develop some relationships between the expressions that are provided up here, okay? So hopefully maybe you recognize an expression here that or an idea or concept that those two things should be equal. Those two angles are vertical angles, so we automatically know instantly that 5x equals 5y minus x. Okay. Now that's kind of a problematic thing or an equation developed because it has two variables in it. So the next thing we want to do is look at the exact same picture, but maybe look at a different grouping of angles. Hopefully you recognize that those two angles should be a linear pair, so they're supplementary. So there I get, when I add things together, I'm going to do this addition right away. So 5x plus x gives me 6x. Then I got plus y, and they should add to 180. So that's adding those two angles together. Again, I've got two variables. Okay, so maybe not the greatest equation there to deal with. So then I look at another grouping, and I look at those two. And now I get y plus 5y gives me 6y. Okay, but x plus negative x gives me 0x. I usually want to write that down. And then they sum to 180. Okay. Now if I look at these three equations, I just know the number. I'm 1, 2, and 3. I can actually solve for x and y using the blue and red equations. Okay. It's not as easy as it is to solve using this equation, but if those are the only two I came up with, we can go through the math to do that. All right, sorry about that, I got interrupted, but these two equations, we can set those together using a system of equations to solve this, but it's not necessary because over here we've got y equals 30 from that information. So now if y is 30, here is where you do need to use these to help you solve for x. If I have now y is 30, I can plug into this equation because it's the same y. So now I got 6x plus 30 equals 180. 6x then equals 150. Okay, x then is equal 6 going to 15 two times, give me 3. So what, 25 times? Yeah, that makes sense. 6 quarters is $1.50. So we get x to be 25, y to be 30. Okay, you would have gotten the same thing, like I said, if you would have taken. Now it's a little bit harder, but taking 5x. Take the red equation, I'm going to write all my x's on the left-hand side, so it would actually give me 6x. I'm going to write all my y's on the left-hand side, so it gives me negative 5y. And then I write all my constants on the right-hand side. It's kind of not as obvious, but I moved everything over there, so I left with 0 on the right. Then I take 6x plus y equals 180, which is this equation here. Okay. Now I'm going to add straight down. But the problem with adding straight down here is I do not get rid of a variable. So what I'm going to do, I was going to go put a negative there, a negative there, and a negative there. I multiply everything by a negative 1. Now your 6x's cancel out. It gives me 0x. It's going to be negative 6y equals negative 180. Divide both sides by negative 6, and I get y to be 30. The same exact value that I got over here. Okay. So 10 is that way. I think 11 is very similar to that. Okay, so again, I'm going to set up all the relationships I can set up. I'm going to say that 4y plus 3x equals 180. That's those two angles. I'm also going to say then that these two angles add up to 180, so that gives me 4x plus y plus 5 equals 180. And then I'm going to set up the relationship that these two things are equal. So I get 4y equals x plus y plus 5. Now this one, these equations, equation 1, 2, or 3, is not as easy to solve as what the last one was. Okay, one of those was an equation you could directly solve for y. Now you can't do that. So now what you have to do is that system equation technique. And you can use any two of the three equations you want. I'm going to use the red one and the blue one. So I'm going to take them and set them equal, or set them on top of one another. So 4y plus 3x equals 180. And now I'm going to take the blue one, and that's going to be 4x. So I'm going to stack the 4x's positive 4x. Say positive 1y, and I'll move that 5 over to get 175. Okay. Now I don't like this because when I add straight down, nothing cancels away. And what I actually have to do is now multiply the bottom one by a negative 4. I'm going to get my y's to go away. So that's going to give me this bottom equation to be negative 4y minus 16x equals, now 175 times 4, 400, 700? Double check real quick. 175 times 4, 700. So it's negative 700. So we use the negative 4. And now I'll have the red one. I didn't change it at all, so it stays 4y plus 3x equals 180. And now I add those straight now. So what that's going to do is going to give me, those are going to go away. So give me negative 13x, 3x plus negative 16x. And then the 180 minus 700 is going to give me negative 520. Now I'll divide both sides by negative 13. And that gives me x to be 40. Now if x is 40, you can plug that back in to that equation right there, or that one, any one that is true for your problem, and you should be able to get what y is. So I'm going to plug it back into this first one. I'll get 4y. Now plugging x in would give me 120 there for 3x is equal to 180. Subtract 120 from both sides. Gives me 4y equals 60. Y then has to be 15. So x is 40, y is 15, and that's how you would approach that problem. Jumping to 17 and 18, I believe these are instructor created. Yes, and they're exactly the same concept. Now there's a lot of different relationships you can say here. Just kind of start you on one of these. You could say, those two are supplementary. So 2x plus 3y plus 2x minus y equals 180. You could say that these two are supplementary, so 2x plus 3y plus 110 equals 180. And hopefully you can start going around, maybe set those two equal to 180, 2x minus y plus 70 equals 180. We've got the idea that these two are vertical, so we can say 2x plus 3y equals 70, and then we could say these two are vertical, and that gives 2x minus y is equal to 110. Okay, I would think any of those are options. I would think that maybe the easiest thing is to really deal with probably the vertical relationships. It's going to be smaller equations. Those are probably the best two to look at with that one. But you can use any of them as long as they garner x and y values that exist. You'll be fine. And a couple of these play over into assignment 2.6 day 2 as well. So hopefully these these examples will help you guys. Have a good evening.